We are back at AP Review. This is 2007 BC Free Response 6, the obligatory Taylor-Maclaurin question. Let f be the function given by f of x equals e to the negative x squared. Part A, write the first four non-zero terms and the general term for the Taylor series of f about x equals 0. So the trick here is that they're not telling you that you have to know the Maclaurin series for e to the x, but you totally have to know the Maclaurin series for e to the x, right? So e to the x is a 1 plus an x squared over 2 factorial plus an x cubed over 3 factorial plus x to the n over n factorial. Now, you don't have to write that out, and you're getting 0 credit for it here because they didn't ask for it. But you're going to use that series, and you're going to plug in a negative x squared anywhere that you see an x, and that's going to be how you find your f of x series. So in part A, again, you don't have to write that down because they didn't ask for it. You just have to know it, right? So the first term is going to be a 1 because there's nowhere to plug an x in, right? The next term is going to be a negative x squared, right? And again, you don't need parentheses there. That's up to you, right? The next term is going to be a negative x squared. Sorry, there's a squared there. Quantity squared over a 2 factorial, right? The next term is going to be a negative x squared quantity cubed over a 3 factorial. Right? And then the nth term is going to be a negative x squared quantity to the n over n factorial plus right? So if you clean this up, because that's what they asked you to do, is they asked you to give them this nice series, you're going to get a 1 minus an x squared plus an x to the 4th over 2 factorial minus an x to the 6th over 3 factorial plus If I were you, I would make the negative 1 alternating, right? The negative 1 to the n, x to the 2n over the n factorial. You don't have to do that, but that's what I would do. It's easier to split the negative 1 off and then just recognize that you're getting the powers of n that are even and put the ellipsis at the end because it does keep going. So this is what they want. Do the quick double check to make sure you did exactly what they asked for, right? They specifically said the first 4 non-zero terms, 1, 2, 3, 4, and the general term, right? Please don't lose a point because you didn't read the directions and they said 4 terms, but you wrote 3. You're just going to get really bummed about that. All right, cool. Part B. Use your answer to find the limit as x approaches 0 of 1 minus x squared minus f of x all over 4. Okay, so part B, they want the limit as x approaches 0 of a 1 minus an x squared minus f of x all over this x to the 4th. Okay, so here's the thing. If you plug this whole series in, what I want you to notice is that when you subtract f of x, it is not an accident that this thing aligns perfectly with the first 2 terms. So when you plug this whole thing in here, these guys are going to cancel with these guys, and you're going to end up getting all of these terms after that. So what's going to happen is you're going to get that this is the limit as x approaches 0 of this x to the 4th over 2 factorial minus x to the 6th over 3 factorial plus a bunch of other stuff, x to the n, negative 1 to the n over n factorial times next to the 2n, all over this x to the 4th. Here's why that matters. Okay, the reason that matters is that because these terms are gone, this x to the 4th can cancel out of every single term. And what's going to happen is when it cancels out of the first term, you're going to get that this is the limit as x approaches 0 of a 1 over 2, because that's what 1 over 2 factorial would be, minus a bunch of stuff that still has x's. An x squared over a 3 factorial plus all sorts of stuff that has x's, right? So when you plug in 0, you're going to get this is a 1/2 plus a bunch of zeros that don't matter. So you're going to end up getting a half. And that's it. They just want the answer, right? But again, what matters here is that essentially all of the terms after this first term will have x's still, and when you plug in x is 0, you get a 1/2 plus a bunch of zeros. All right, so it's a 1/2. Part C. Write the first 4 non-zero terms of the Taylor series for the integral from 0 to x of e to the negative t squared dt about x is 0. Use the first 2 terms to estimate the integral from 0 to 1/2 of e to the negative t squared dt. Okay, so I really need to write this nth term for my f of x series because that's what's going to matter and that's what we're going to have to use. So I'm going to write this at the top so that we have it, right? I know that f of x is a 1 minus an x squared plus this x to the 4th over 2 factorial minus the x to the 6th over 3 factorial plus negative 1 to the n x to the 2n over an n factorial, right? So that's what I'm going to need later. So I'm going to keep that because we're probably going to have to use that nth term a couple of times. Okay, so in part C, we are asked to integrate from 0 to x of e to the negative t squared dt, right? And we're asked to write the first 4 non-zero terms. Okay, so what they're asking me to do is integrate this, right? That's the trick here, right? And they ask for only the first 4 non-zero terms, not the general terms. So essentially, I'm just integrating each one of these terms, right? So what they want me to do, if I integrate 1, right, I'm essentially, and again, it's up to you how you do this, like, all the bottom bounds are zeros. So if you can just skip the step where you don't care, right? I mean, what they're asking me to integrate is 0 to x of a 1 minus a t squared minus a t to the 4th over 2 factorial plus minus a t to the 6th over 3 factorial plus da-da-da-da-da with respect to t, right? So that's what they want me to integrate, is this whole thing with respect to t. If you need the extra step to show that you're plugging in the bounds, that's fine, but when you integrate each one of these and plug in the top bound that's an x, they're all going to get x's, and the bottom bound is just going to be a 0, and they're all going to 0 out because every single one of these is going to have a t. So when I integrate the 1, I get a t, but again, I'm plugging in the top bound, it's an x. When I integrate the t squared, I get a t cubed over 3, but again, when I plug in the top bound, it's going to be an x cubed over 3, right? When I integrate the t to the 4th, it's going to be a t to the 5th, over a 10 now, because that was a 2 on the bottom, right? 1 times 2, so now it's a 10, so plus it's an x to the 5th, because I'm plugging in the top bound, x to the 5th over 10, right? When I integrate the t to the 6th, it's going to become a 7, and there's already a 6 in the bottom, because that's what 3 factorial is, so it's going to be a minus an x to the 7th over a 42, right? Plus dot, 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 right? And that's it. That's all they wanted, was the first 4 terms, right? And so I'm able to say equals, not approximate, because notice that what I did is I put the ellipsis at the end, right? So it is equal to this, and that's all they wanted, were the first 4 terms. Did it. Okay, cool. Second part of the question said, use the first 2 terms only to estimate what happens when you integrate from 0 to 1/2, right? Okay, so essentially that's going to be plugging in a 1/2 to the first 2 terms only, right? So the integral from 0 to 1/2 of e to the negative t squared dt is going to be approximately, if I only use the first 2 terms, a 1/2 minus a 1/2 quantity cubed over 3, right? Well, that's a 1/2, right? This would be a 1/8 divided by 3, so that's a 1/24. So if they're both over 24, I get 12 24ths minus 1 24th, so I get 11 24ths, and that's the answer for that approximate value, right? So that's the approximate value. Part D. Here we go. They asked me to use the first 2 terms, so part D is going to be asking me to use the error, which is just the next non-zero term. Explain why the estimate found in part C differs from the actual value by less than 1/200. Okay, so if I use these terms, I'm maxing out this term to find error. So in part D, right, in part D, we want to max out the next non-zero term on the window from the center, which is 0, to the point I plugged in, which is 1/2. Well, that's this guy. So the error, right, the difference between the actual and the error should be, so my error, right, which is the difference between, and actually, so essentially the difference between this thing, 0 to 1/2 e to the negative t squared dt minus the 11 24ths. If you want to be really picky about it, that's the actual minus the estimation, right, is less than, it has to be less than or equal to this term maxed out, which would be, again, in the absolute value, a 1/2 to the 5th, which is a 1/32 divided by 10, and I'm supposed to show that's less than a 1/200. Well, 1/320 is absolutely less than a 1/200, so there you go, right? So that's my job, is to show that this thing maxed out, right, the next term maxed out, is smaller than whatever arbitrary number they gave me, but it's not really an arbitrary number. It's going to be a number where you can clearly tell that this thing, bigger denominator is smaller fraction, is smaller than this thing, and that's what they wanted.